Hi all, this is Dr. Namatofas Fakasuja. I'll be taking you through Data and Information Management 1. This is Bachelor of Software Engineering, Year 1, and I am in the Department of Information Systems at the College of Computing and Information Sciences. So we're going to look at the introductory bit of Data and Information Management. And the objectives of this course are: one, we're going to for this particular topic, we're going to look at data, information and its relevance. We shall be looking at the manual filing system and the challenges, and the characteristics of the file-based system and their challenges, the database approach, the different types of database management systems, the functions of the database management systems and the components, advantages and disadvantages. And then finally, we shall wind up with the roles or personnel in the database environment. Many of us know what data is, and we're saying that data is a stream of raw facts that haven't yet been processed. And in this case, you're looking at things like symbols, numbers, alphabets, and many others. Information, you're looking at processed data. When you put together the alphabets, the symbols, the numbers, and so many other things, and you put them together to make meaning, that is what referred to as information. So then we have what we call the file-based system, and we're saying that before we get to what a file-based system, we need to understand what a file is. So a file is a collection of records which contain logically related data. And when you're talking about logically related data, is very important in the computing or in the database environment. Data has got to be systematic. It has to be related to each other. So you can't get data about a school in the database and then you mix it with data about, let's say, data about a telecom company or banking and so many others. So when you're looking at a file, usually a file will have records that are similar or the same. In other words, they are logically related. So the file-based system here, we're looking at the collection of application programs that perform services to the end users. So each program defines and manages its own data. For example, if you look at Microsoft Word, if you look at Microsoft Excel, all those are some of the file-based systems where each and every particular program does manage its own data. So the better alternative was the paper-based filing system. So this is an example of a file-based system. For example, you have this employee file-based system, and then also you have the student, you have the employee table, and then you also have the student table. You can look at it in that perspective. And then you have this employee information that is being, let's say, saved somewhere in an Excel sheet. And then also you have the student data that could be saved somewhere, let's say in a Microsoft Word document, or it could be any other kind of document. So that is what we refer to as a file-based system. However, this file-based system had its challenges, and these challenges, we're going to discuss them one by one, and it is from these challenges that we saw the evolution of the database. So what were these challenges of the file-based system? You're looking at the separation and isolation of data. Each program maintains its own data. By virtue of the fact that each program maintains its own data, it becomes a little hard to maintain that data. So for each program to maintain its own data, it becomes a little tedious, it becomes a little hard. And then there's the aspect of maintenance, the updates, and many other things that come with separating data. So that is a very big challenge. And of course, users who are using different programs will not potentially understand the usefulness of the other program, because each and every particular user is using a different program. So the other disadvantage of a file-based system is the duplication of data. Like I have said, the two previous examples, we see the data of employees and the data of students. These are two different programs that are managing the data. So you might have to duplicate this data. You might have to, for example, in a university setting, you're going to have data of a different college stored in a different place, and then you're going to have data of a different college also stored in a different place. So you are going to have duplicated files on different machines or in different offices, which would potentially have been one consolidated file. So that alone has its drawbacks, because it means that if one file is updated, then there's a possibility of the other file not being updated. Then secondly, also there's space, disk space. Because if you're going to have different files being stored in different locations, then that means you're going to be using a lot of disk space. Then we have data dependency, unhealthy dependency between the data and the program. Now, with the file-based approach, you have a scenario where you have the data is dependent upon the program within which you have designed or formulated the data. So what does that mean? It means that in the event that you don't have the software, then also that data will not be usable, or it will not be useful, because the data is dependent on the program. So for example, if you have Microsoft Word, you have data that is in Microsoft Word. Now the data is going to be dependent on Microsoft Word. Should you put the data on the flash and then you take it on the computer that does not have Microsoft Word, unfortunately, not be in position to open it. And that is part of the reasons is because of the incompatible file formats, which is our next point. So programs are written in different languages, and so it becomes very hard for you to access the particular data that was in a different program to access it in another program. So it becomes a little hard. So that is another drawback of the file-based system. And then you have these fixed queries, which becomes a little hard for you to carry out customized queries. So programs are written to satisfy particular functions, and in the event that you have new queries or new requirements that you need your program to run, then it means that you may not be in position to do that. So that is also another example of the file-based system. Those and many others can really be were the reasons as to why there was database systems, the evolution of the database systems. So when you're talking about the database system, you're saying that what does it do? What did it come to do, or what did it come to solve? So databases were developed as a solution of the limitations of the file-based system for storage and management. So the definition of the data was embedded in the application programs rather than being stored separately and independently. And this is what happens with the databases. The databases the data is separate from the program. So you have what you call program data independence. And then we have no control over access. Access to data is, of course, limited. And therefore, there was a need to separate data from programs and with a facility for them to interact. In other words, having those different programs interact and also having to separate data from the applications within which you have designed them. And therefore, the database was the solution to be able to do that. So the database helps to store the data, while the database management system helps in the organization and the securing of the data. And okay, so what that brings us to the definition of the database. So what is the database? It's simply known as organized collection of logically related data. The data that is stored in the database has got to be logically related. So why are the databases important? One, they help us in the manipulation and management of large data sets, and also they help in the integration of data that is coming from multiple sources. So we have different, there are different characteristics of the database. For example, a database is a single repository of data. In other words, you're having only one location where all the data from for example, if we look at an organization like Makerere University, you have different colleges, and within the different colleges you have different schools, and within the different schools you have different programs, but all this data is being collected and managed in a central repository, which in the long run helps in the sharing of data within the different users, but also it helps in updating, becomes very easy, and therefore it ensures concurrency. Then data in the database is self-describing. What does that mean? It means that a database has what we call a catalog. A catalog helps to keep data about data. Sometimes it's called a dictionary, and other times it's called metadata. So a database helps in describing data within itself. So you can have a catalog that contains information about the different definitions or your database objects within the database. Then the other characteristics is the multiple views. In other words, it means that you have different users who are going to have different views or different interfaces. So if users have different, a manager will have a different interface, a secretary will have a different interface, a receptionist will have a different interface. So a database is in position to do that, unlike the file-based systems. And then we have the program data independence. Like I had earlier mentioned, I said that databases help in dealing with data dependency issues that we saw in the file-based system. So here in the data independence, you have the data being separate from the program. So when you have your database, for example, on a movable flash, it means that you can be in position to open it in another database management system. For example, if you designed that database in SQL, you can open it in any other database management system. So it refers to, so in other words, there is that immunity of the user applications to make changes in the definition and the organization of the data. So there are certain circumstances with when to use a database and when not to use a database. So for example, we're saying that the circumstances under which you may not be required to use a database is if there is a real-time constraint to the application availability. Okay, if there is that constraint, then you do not need to use a database. If the speed of the application is critical, because in most cases we tend to have databases running very slow unless you have improved on the hardware architecture in your organization. Then if the data involved is very small, there is no need as to why you really need to have a database. And if, for example, you have an organization that is either a project, it is going to be in existence for a specific period of time, or its existence is short term, then you can do away with a database. So we're going to look at different terminologies in the database. We have what we call the database application. It's a program that interacts with the database at some point in its execution. So in other words, it helps us to access the database, it helps us to process the data that is in the database, and also to generate the data that is required. Then we have a relational database. A relational database, we shall talk this in depth when we are covering our topic 3 and 4. But a relational database is usually a tabular structure that helps us to store data, and this tabular structure is in form of rows and columns. Then you have a database management system, the software that helps us to create, maintain. It helps us also to manage the data that is in the database. So one thing that you need to delineate is we have what we call a database, which is the actual data, and then you have the database management system, which is the software that helps us to manage the data that is in the database. So we have database languages, we have the data definition language, you have the data manipulation language. The data definition language, this permits specification of data type, the data structures, and also looking at the constraints. So in instance here, in the data definition language, you're looking at the tables that you're going to have in your database, you're looking at the attributes, you're looking at the domain, you're looking at the index, if you're going to have things like index and so on and so forth. So those things that make up the structure of the database, we collectively put them in the data definition language. Well, the data manipulation language, this one helps us in the insertion, in the update, deletion, and retrieval of data in the database. So an example of the data manipulation language is the structured query language. So when you're looking at a database management system, this is how you'd look at. You have this database here, which is the actual data. Then you have this database management system, which is the software that interacts with the data in the database. Remember, we have said that this database management system is in charge of creating, it is in charge of manipulating the data in the database, updating and deleting the data in the database. So in essence, it is the one that helps us to manage the data in the database. And remember, we talked about the data independence. So you can say that here is your data, but it is independent of the software that helps to manage the data in the database. So you have this data entry and reports, and then you have these two. These are the users that interact with, let's say, a sales system, and then you have another user who is interacting with the contracts system. But all these things, all these subunits or user views are consolidated into one system. So we have different types of database management systems. We have what you call a single user, and then we have a multi-user database management system. A single user database management system supports only one user at a time. It means that if user A is using the system, B and C and Z will have to wait until A exits the database. And then we have the multi-user database management system that allows different users to access the database simultaneously at the same time. So when we're discussing the components of the database management system, we have the hardware, software, data, procedures, and the people. So those are the components of the database management system. So we have the hardware. The hardware and the software lie on the machine. The hardware are the tangible components of the system, whereas the software are the intangible components of the system. The hardware, you can touch it, you can feel it, you can see it, whereas the software, you cannot touch it because it is intangible. Then you have the procedures. These are the instructions, these are the rules, the policies and procedures that we have to put in place in order to use the database. So these rules usually are set up. They are set up either at the time when you are developing the database, or they are set up at the time when the database has already been commissioned. Then you have the people who interact with the system, and of course we have different kinds of people that interact with the database. We have the database designers, the database administrators, application programmers, we have end users, and many others. Then we have the data itself. The data itself, we're saying that it acts as a bridge between the machine and the human component. And it is that we use. And it is that becomes very important and critical to the organization and the people at large. So earlier on, I said in the introductory part of this lecture, I said that we're going to discuss the roles of the users. Of the different people in the database environment. We have the data administrator, who is responsible for the policies in the organization. Usually this person is not technical in nature. So the data administrator, what does he do? He can help in the planning of the system. He can help in the development of standards, policies, and procedures of use of the data in the database. And then also they help in taking part, for example, at the time of conceptual design of the database, these people help in taking part. Then we have the database administrator, who are actually technical. They are much technical than the data administrator, and they are in charge of the management, control, and the establishment of the database. What do? They help in granting user authority to access the password through assigning usernames and passwords to the people or the different users. And then they help in specifying the integrity constraints, that is the primary keys, the secondary keys, the business rules. And then also they monitor performance and responding to the changes in the requirements of the database. So in essence, they help in monitoring the entire functioning of the database, and should there be reason for changing the requirements of the database, these people are the ones that are in charge. Then you have the database designers, and specifically you have the logical database designer and the physical database designer. The logical database designer, when we go into, let's say, the second part and fourth lecture, we're going to see how logical database designing is different from physical database designing. But to throw some light, a logical database designer will be in position to structure out, to come up with the structure of the database in terms of attributes, entities, relationships, domains, data types, etc. This is what the logical database designer does. And the physical database designer is in charge of ensuring that your security protocols for the data have been put in place. If you're going to use things that are a little technical are instituted within the database environment, and that is the physical database designer. So this physical database designer is essentially in charge of the actual programming of the database. So the actual, where we see a live database, all these things are done by the physical database designer, who also works as an application developer, who can also work as an application developer. These roles are not very, they are not specific. A logical database designer can be a physical database designer, and they can be application programmers. So usually the roles tend not to be very explicit, and they are not mutually exclusive. Then you have the end users, who are either naive users. They know what to do with the data, but they are not technical people. And then you have the sophisticated users, who can also play the role of a systems administrator. They can also be, they can actually be programmers. So those are the different kinds of users. So what are the advantages of the database management system? From what we have discussed, what you need to know is all the challenges of the file-based systems are actually the advantages of the database management system, and many more. So control of data redundancy is our first point. If you look at the file-based system, there is data redundancy, where the same information or the same file is being stored in the different location. In the database, we say that you have what you call a central repository where all data is being managed. So that means there is control of data redundancy. You don't have duplicated data. Then we have improved security. If you're looking at the database management system, you have usernames and passwords. You have the enforcement of integrity constraints, for example, where you have primary keys, where you have foreign keys, and many others. The enforcement of the business rules. So all these are some of the security features that you're going to find in the database. And therefore, it becomes very easy for us to trust the data that is in the database because of these different security enforcement mechanisms. Then we have increased concurrency, okay? We're saying that if in some file-based system, if two or more users are allowed to access the same file simultaneously, the accesses may be interfered with one another because there is nothing like concurrency. But when you're looking at the database management system, you have a scenario where you can have numerous users accessing the database at the same time, so implying that you can have as many users as possible to access the data, and therefore it increases on concurrency. Then you have improved data accessibility and responsiveness. Again, that comes it can draw from the previous point where you have data that crosses departments. Okay, you have one department could be working with, for example, completely numerical data, like the account department, and then you have the other department that could be working specifically with, let's say, string data or objects or maps and so on and so forth. So you have all this data that is being condensed in one central repository. So what does that mean? It means that when it comes to access of data, no one is going to be hampered because you have different data that has been stored in your database. So when it comes to data accessibility, it is very easy to access data because you don't have to wait for one person to use the data and then you also use, but also most importantly, you don't have to move from one place to the other to look for data. The data is in just one place. All you need is a username and the password, and then you can access that data, which is not the same thing with a file-based system. Improved backup and recovery services. In the database management system, it provides the facility of minimizing the amount of processing should there be a failure at any given time. Okay, recovery becomes easy, backup becomes also very easy. So when you're looking at the database, for example, we say that you have this one place where information is being stored. So when at the point of recovery, you're only looking at that one point where you're going to either use some kind of software to recover the data or whatever technique that you're going to use. But in the scenario where you have the file-based approach, it means that you have different locations where data has been stored, and therefore at the point of recovery, you will have to go to those different locations to be able to recover the data. It's kind of tedious. Sometimes it's even not achievable. It's not even sustainable. Then sharing of data, like already explained, you have one piece of repository, so sharing of data becomes very easy amongst the different users. Then data storage is easy, retrieval and update because of, again, the central repository. Then authorization, because everyone has a username and password. So the authorization services, the database management system is in position to authorize each and every particular user through a username and password to enter the username. These rights are enforced at the point of developing the database. Then you have transaction support. Most databases, especially if you look at banks, if you look at educational institutions, they are transactional in nature, where you have to constantly input data, and then there's manipulation of the data, and then you're expecting a certain input. So those are transactional in nature, and the database management system is in position to handle these transactions. And then you have integrity or reliability services. Integrity is where data is kept in its original format without being changed by any unauthorized personnel or any unauthorized person. So the database management system is in position to keep the data in its integrity. How? It has what we call an authorization service, where people are given usernames and password. But on top of that, we have what we call the integrity constraints, like the primary key and the foreign key. At this particular moment, it might be a little hard for me to explain what a primary key and a foreign key is, but as we move forward, you will remember that I mentioned a point on integrity. So integrity is enforced through a primary key, through foreign keys. We have what you call refresher integrity rules. We have what you call entity integrity rules. All those things are done by the database management system, and then it means that we are able to keep our data intact. Then we have the database management system further promotes data independence, that is where data is dependent of the program. What are the disadvantages? Complexity. It is very hard, to develop a database. It's very, very hard. So it has several components which need serious and careful planning if you're going to have a very good database. So database management systems are very complex, and then also they tend to be very large in size. So that means they take a lot of disk space and memory, and then they are very expensive, especially if you're looking at the database management system that is going to manage over 100 users. So it means you have to buy a license. An example of Oracle, an example of SQL or SQL, all these are very expensive database management systems. And these are the systems that you want, especially if you have a company that has many users. And then also there are additional hardware costs. If you're going to run a database of over 100 or 1,000 users, then that means you need to increase on your storage, and also you need to increase on your memory. Then the other disadvantage is the cost of conversion, for example, where you have your data that is running in a particular application, and then you need to shift or convert the data to a database management system. So the process of having to migrate data from one system to the other, you have to employ specialists, you have to train staff on how to use the new database management system. All those have a cost implication. Then you have performance, okay? Like I had earlier mentioned, that usually databases tend to be very slow. And if you want your database to be very fast, that means you have to invest in more hardware requirements. And then on impact on failure, usually because the database has huge sums of data, it means that at the time when your database management system will stop to run, or when there is a fault, it means that the impact is going to be colossal, because many people will not be in position to transact, they will not be in position to do so many things because of the database, because of the failure of the database. So those and many others are some of the disadvantages of the database management system. That said, it doesn't mean that it makes it less advantageous on the file-based system. Of course, the database management system is much more advantageous than the file-based system. So this is the end of our first lecture. I believe that we shall be in position to proceed with the second lecture. Thank you very much. Have yourself a good morning.